Hi and welcome again, Math 212 students. We are looking at geometry's measurement today. Going to be looking at our different systems of measurement in section 9.1. Let's see the Common Core standards for this section. You'll be needing to discuss these systems of measurement in kindergarten through 5th. We're going to take the day that we analyze and we're going to take a measurement of something, and you're going to take your students and you're going to have them start measuring things. In second grade, we're looking at those different units that we're working with, and we're going to have to start going from one unit to another. Here are different topics for today. First up, we'll discuss time. Here are my different conversions for time, and the reason systems of measurement for time were developed so that we could know when we were all going to get together for a ritual, or when we were all going to get together to go hunt or plant, that sort of thing. Length, we have all kinds of crazy measurements for length. A foot, a hand, we still measure horses in hand, yards. This is how these different measurements were developed, and you can notice that this would depend on what size you were as to how big a foot was. So, and what we started to do is try to get some sort of uniformity in these different measurements. So the Roman writer Plutarch stated that the foot was based on the actual length of Hercules' foot. A cubit was the distance from your tip of your middle finger to your point of your elbow. The French foot obviously would be the length of King Charlemagne's foot, of course, and then a yard would be, of course, a measurement of some king once again. But what happened with this varying type of measurement would be that people would get cheated. If you bought something, you would want 1 yard in one place to be the same as 1 yard somewhere else, and so it became unfair until we had standardized units of measurements. But here's our modern day United States version of our measurement system, what we still go by today. We try to go to the metric system, but you guys will have to, as elementary school teachers, you guys are going to be the ones to try to get students into that system that the world uses today, if that's ever going to happen. So here's another development of measurement systems having to do with weight, and of course we're wanting to measure gold, diamonds, metals, different chemicals or drugs. And then we started measuring three-dimensional objects and volumes. That would be just a regular object, and then we also wanted to measure liquids as well, so all sorts of different measurement units developed, and here we are with our different measurement units. Temperature is another measurement system. Gabriel Fahrenheit, the lowest temperature he could create in the lab was this 0 degrees, and that's what he called 0 degrees, and he developed this temperature scale. And on his scale, the freezing point of water was 32 and the boiling point was 212. Of course, then we had the Celsius, where it was another measurement system where we said that 0 was the freezing point of water and 100 was the boiling point of water. So we have all these different systems that we're looking at, and we're trying to get together, you know, in a place that doesn't have the internet, trying to get together and have some sort of uniformity to our different measurement systems. This is driving home the point that a bushel in one location isn't the same as the bushel in another location, and what ends up happening is the rich are cheating the poor. The United States has not officially adopted the metric system. we don't really think in terms of the metric system. If I was to say that I was 3 meters tall, it's hard for you to imagine what that might look like, and you're still kind of going, well, is that reasonable? If I said I was 2 meters tall, what does that look like in your head? But if I said I was 5 foot tall, you would know exactly how tall I was, because you have that visualization in your head. But the more you familiarize yourself with a measurement system, the easier it is to get that in your head. So having your students measure in the metric system as well as the English system will help them to get familiar with this system. Here is the metric system and those prefixes thereof. Meter is the standard unit of length in the metric system, and it says here how that is defined. This just gives you the relationship of the millimeter to the meter to the kilometer. Those are the most frequently used measurements for length in the metric system. Here's the most commonly used units for volume in the metric system. This is a very nice feature of the metric system, is that 1 cubic centimeter equals 1 liter, or 1 cc equals 1 liter. Also letting me know the differences and the relationship between milliliters and liters, and going into the no, it's not going into the English system yet, but we will in just a second. Mass, metric system uses grams and the relationship thereof. Of course, our system uses pounds. With this, pounds would be our weight. Mass is exactly how much matter that makes up an object, so the amount of mass doesn't change if you go from the Earth to the Moon, but your weight does, because weight is a result of gravity. So if you go from the Earth to the Moon, your weight is different. Here's a nice little scale showing me both my Celsius versus my Fahrenheit scale, showing that 100 is the same as 212 in the Fahrenheit, and you'll notice there's 100 tick marks between 0 and 100, and then there would be, let's see, about 180 tick marks in between these two scales, which leads us to realize that it's not easy to go from centigrade or Celsius to Fahrenheit, because there's 100 tick marks in between here, there's 180 in between here, and those tick marks aren't the same spacing. In trying to get a uniform system of measurement, all sorts of different things have been proposed. One of those is that a circle has 400 degrees, just to make it really pretty, and it would just change the spacing of the tick marks. You could change the calendar so that instead of having 12 months, we could have 10 months in a year, 10 days in a week, and 10 hours in a day. Of course, that hasn't caught on. Just so that we would know, have some idea of what these measurements look like, from the floor to about your hips would be about 1 meter. So if I said I was 3 meters tall, you should go, whoa, that's pretty tall, and I am not. And the distance of your pinky toe, or the width of it, is about 1 centimeter, and just showing you those different measurements. Here are some common conversions that we will use in our homework, and I will use that in doing a couple of different problems for you. So we'll need these conversions in order to look at these guys. So they want me to insert the decimal point in the proper place. So let's get a good idea, because I'm just going to use these conversions at the bottom. So they tell me that the diameter of a penny is about 1.9 centimeters. So let me see right here. This tells me about what a centimeter is. So 1 inch is about 2.5 centimeters. So I bet the diameter of the penny is about 1.9 there. Well, that's a nice decimal point. The length of a page of notebook paper is 279 centimeters. Now that would be way too much. I believe they mean for that to be about 27.9. The common adult height of an elephant is about 39 meters. Now we said that 1 meter was about from your hip to the floor, so that would be a really tall elephant if it was 39, so I think they mean 3.9. Which metric unit represents the weight and volume as described? When I say that the weight of a box of cereal is 425 grams or 425 kilograms, let's see. A kilogram is about 2.2 pounds. So if I said it was 425 kilograms, whoo, that'd be a whole bunch. I probably would have to be this guy right here. The volume of a cup of coffee is 250 liters or 250 milliliters. Well, let's see. A liter is just over a quart. So would that be like 250 quarts? I don't think so. So it would probably have to be this guy right here. Alright, so let's go on to the next one. When I work with the metric system, my favorite is to use the metric staircase because that tells me how to move my decimal point. So a path is measured 1.5 kilometers. How many meters is this? If you go up the stairs, you move your decimal point to the left. So decimal left. If you go down the stairs, you're going to move your decimal to the right. And one of the things we usually use is some sort of mnemonic. You can have your students come up with their own. I know when I was in school we used kangaroos hopping down Main Street because this is my main unit here. Kangaroos hopping down Main Street drinking chocolate milk, and we would make the stair step just like this. So if a path is measured to be 1.5 kilometers, how many meters is this? So I'm going to write the 1.5, and I go from kilometers to meters. So I start at the step and I walk 1, 2, 3 places. So I would just say 1, 2, 3, move the decimal point 3 places to the right because I went down the stairs. And this answer is 1,500 meters. So for A, I'm going to write 1,500 meters. A recipe calls for 250 milliliters. So I start down here at milliliters. I'm going to my liter there, which is my main unit here. I usually star it. And I'm standing here on the step, and I would walk 1, 2, 3, 3 decimal points. So I have 250. And I move it to the left, 1, 2, 3. So there's where my new decimal point would be. So I would write 0.250 liters, and you can write 0 point if you want. A sample weighs 750 milligrams. How many grams is this? So I'm sitting here on milli, and I'm going to my main unit, which is grams, and I would walk 1, 2, 3. So that would be 1, 2, 3. So the answer to C is 0.700 grams. For D, change 235 millimeters to centimeters. So I'm sitting here on the millimeter, and all I have to do is walk 1 step to the left. So move my decimal point 1 step to the left, and the answer to D is 23.5 centimeters. Walking up and down the stairs just makes that so easy. Alright, we have some other quantities that we can measure things in. Noise we measure in decibels. Just a little note on precision versus accuracy. Sometimes we want our measurements to be very, very precise, and sometimes we just want them to be very, very accurate. I think the best way to explain precision and accuracy is to look at a picture. So if you'll notice in the very first target, someone has shot at this target very precisely because all of the arrows or the darts went in the same general location. But they weren't very accurate, they were just very precise. In this next one, they were pretty accurate because they were aiming for the middle. They got all around the middle, but they weren't very precise because they weren't gathered up in one spot. You'll notice that the next bullseye is just kind of all over the place, neither precise nor accurate. And then our last bullseye is both accurate and precise at the same time. All right, well, that concludes Chapter 9.1. If you guys have any questions or if you need any extensions or need anything else, please let me know and just send me an email for that. Thank y'all.